Hi everyone, and today I would like to share. Okay, just waiting a second. So today I would like to share research of our team with regards to anomaly detection applications to biosecurity and climate. And we're gonna travel for this presentation from Christchurch all the way to Antarctica. So we'll start from Christchurch. Okay, so just this work is part of our TAIAO research streams on biosecurity and on anomaly prediction. And one other topic which is going to be covered today from our University of Canterbury with regards to anomaly prediction is going to be in the afternoon, so I'm just going to advertise it. So it's by PhD student Ding, who is here, and is going to be on marine heat waves. But in this presentation, we are going to talk about biosecurity and wind prediction. So let's start with biosecurity, and without no doubts, if you ever traveled from New Zealand from overseas, you might recall that there will be some cute dogs in the airports which will go to your luggage and try to find whether you're trying to import some unwanted goods. So why do we have this issue? Why do we need to care about biosecurity? Well, because invasive species is really, New Zealand conditions are really good for establishment of invasive species. And because primarily New Zealand relies on agriculture, we really don't want to let those invasive species to ruin our production. So what is it to do with urban environments and with trees? So basically, what if you look at the map of New Zealand, we can see that there are several ways we can import goods in the country through airports and seaports, on which we can see those major points of entry. But what happens near those seaports or airports? Basically, we have trees, not surprisingly, growing in our cities, and you can see on the left, basically, on the left-hand side map of Christchurch with all the trees located conveniently. We have this database from Christchurch City Council. So what actually it means? Well, it means that we can check if some invasive species suddenly gets established in cities by looking at trees and what is happening with them. So one such example is Dutch elm disease. So basically, this disease is carried by beetle, and it can be seen via trees changing the basically foliage. By the time this happens on the top, basically it's a bit too late. So if you see trees suddenly unseasonally changing the leaves, it's not what we would like to see, and we would like to be able to prevent this in time. So basically, what is the idea? How we can catch such threats? But not only these kind of threats, of which we know how the trees might look like, but also some unknown threats, which might be carried by insects as well. So focus here is how we can monitor trees and basically be able to see if something is happening with trees in the cities, which is not quite right for the season. So basically, our idea is to build digital twin database of trees in urban environments, for which we chose several regions. So one is Christchurch, another one is Auckland. And the idea is if we have database where the trees are located and we can segment where the trees are, and basically later on, what we're going to do, we're going to put camera on a rubbish truck, and because it goes on a regular interval, what we can do, we can basically find whether something is happening which is not healthy for a particular season, as what we might see here. Well, basically this is what healthy seasonal change look like, and what is unhealthy seasonal change might look like as opposed to the one before. So that's the whole idea. Let's look at our trees. And the first part of this project, which is basically a joint work with the University of Waikato as well as Bioheritage New Zealand, is to build segmentation. Also, would like to mention that not all anomalies might be caused by unseasonal seasons or diseases. Well, maybe someone just came and pruned a tree. So we would like to get rid of this in our database. So not all anomalies are problems. Okay, so again, that's how a setup might, cameras, how a setup might look like. And we're not gonna talk about cameras because I'm not an expert in them. I'm gonna talk about deep learning applications and what we can do if you already have a footage. So basically, the whole idea is to, first of all, start with segmentation models. And for that, we collected data set. I'm just going to skip this part and I'm going to talk about segmentation data set. As, for example, Nick just previously mentioned, collecting data is a really huge challenge. We tried to find publicly available data sets, but there were none for the trees taken from the street point of view. Surprisingly, so there are some databases where people looking from above at the trees from drone or plane. However, we had to collect our own data, for which we employed several summer students. We didn't just, we paid them money, but it's still a really tough job. So we collected 3,000 images, and that's what we used for our training for the segmentation problem. Just to give you an example, so what we are looking at Google Street Views, and it took 60 minutes for that cabbage tree to get segmented. And those are students who are actually studying in forestry. So if you're not quite sure how the tree might look like, it will take way longer. So just to show you the scale of collecting the data set, how it looks like. And actually, zooming in doesn't help. So you will see all these pixels appearing on the screen, which doesn't really help with segmentation. And another example took 30 minutes, for example, with English M tree to get segmented. Nevertheless, we collected the data set and built segmentation model based on deep lab. So there are some other technical aspects. You can ask me later if you're interested in what setup we used. So basically, we got quite good result for this first part of the project for creating digital twins. So again, first of all, we had from Christchurch City Council, we had database of all the trees, and we used Google Street View to basically join it with database of the trees and build a segmentation model. So we knew where the trees are from this database. That's how we got our labels. So first of all, let's start with not so good looking results. So what we got from segmentation, basically, we had several species which were identified, but actually in the ground truth, we only were interested in one tree. Okay, so there is still room for improvement, basically, for these results. However, some of the results looks quite promising. So, for example, this standalone tree got very well segmented, and the same goes for if we had several species, or for example, in this case, this cabbage tree presented in our view, then the model selected them quite well. I should also mention that we are not interested to look in people's backyard. That's what we don't want to do. And that's really bad. So for privacy reasons, what we're going to do next is basically why we want segmentation, because we want to blur the background. So we don't want it to be stored. That's why we are not actually interested in the trees which are growing in people's backyards and only on the street trees. And in this example, we can see that we only detected those street trees here. Well, this is just another example where we have trees growing on the street as well. And those are English oaks in this case. So when I was talking about deciduous trees, basically we have trees which are exotic for New Zealand and not native. And that's where those insects might get primarily established. However, we would like to see various species and track how they might change over time. So basically, this is the first step towards this application of digital twins of trees, and the project is still ongoing. So I really encourage you, if you are interested in Christchurch trees, you might try this website and have a look for yourself, whether you might find some trees to look at. And I invite you to come in spring to Christchurch to have a look at cherry blossoms. Very good seasonal change. And I hope this work will help with identification of invasive threats. What I also wanted to talk about here is work by another student, PhD student Tobias, and it's a bit of change from trees. There are no trees here because we're in Antarctica in dry valleys. Okay, so, and this is a different application or different kind of anomaly. So basically, if you're looking at trees and anomaly with the foliage, here we can't really see anomalies, but we can measure them. So basically, here we're interested in detecting anomalies, wind conditions. Again, if you've ever been in Canterbury, you might experience really hot, sudden wind. Basically, it's almost always followed by really cold snap from Antarctica. So basically, those are so-called fern winds. What is interesting about them? Basically, they can melt ice, and the temperature change by which the temperature gradient is around 40 degrees. So this is quite prominent. And what can be done here is basically by identifying those events, we can know in the future climate models whether we might have more frequent events. And for this, we basically used autoencoders. And I will show you in a bit how we basically use those models to identify anomalies. Basically, now we don't have images anymore. Instead, we have time series. And we have time series from several weather stations, and those are time series of temperature, humidity, wind speed, and other conditions. So basically, the whole idea of this so-called autoencoder models is be able to basically mimic normal conditions. And I will just show you how the normal conditions might look like in Antarctica. It might be quite cold, especially this time of the year. But this is normal day without sudden changes either in humidity or wind speed. And that's how most of our examples look like. And if you have fern wind events, which is really high temperature and high speed, we can notice by eye those changes. However, we would like to have a more comprehensive approach and not just go through the data set and apply some heuristics as researchers actually used in the past. So we'd like to detect those anomalies automatically. So basically, because most of the data are normal, so we can try to replicate them, basically using autoencoder model, which takes time series in and produces time series out. And the idea is, well, because most of our data is so-called normal days, like on the top, so basically most of this time series will be represented quite good, and the error will be quite small. However, for anomalies, the error is going to be much larger, and we're going to measure this error. And if the error is above a certain threshold, we can identify these days as having fern wind events. Basically, that's what happened in this work, and this work is still ongoing. And basically, after building this data set, we would like to take a step further and find what might cause these events, and basically have a look at anomalies, temperature changes around Antarctica, and the next step is apply explainable AI to basically see what might be driving these events in this part of the world. Okay, so hope I gave you some flavor of different kinds of anomalies, and thanks very much, and I'm very happy to answer questions.
Thank you, Varvara. Time for a quick question. Yes, Sebastian.
So first of all, we tried automated segmentation models, and well, we were not really satisfied with the results. So basically, there was the first application, and the second one was to refine these results, because some of the trees, they basically have very intricate structures or branches, and that was very crucial for us to be able to capture them. So we couldn't really have out-of-the-box models, unfortunately. That would be quite easy if you could. Yeah.
Thank you. Another, yes.
I was just wondering if it's a really tricky problem to solve with monitoring these trees from possibly viewing angles. Do you have a way of determining where the camera is in relation to the tree?
Thanks. Yeah, I think that's a very good question. In terms of monitoring from different angles, we will need to think carefully next step, basically how we're gonna compare what we have in our viewpoint and what happened during when the next time track passed over. That's definitely a thing to consider.
Awesome. Thank you very much, Varvara. Thank you again.